want to know, he said to me, was an empress over many peoples, by the vice of luxury so subdued that she made lust lawful in her domains. She is Semiramis, who we read, succeeded Ninus or Spax. She held the land that now the Sultan rules. The other is she, Dido, who killed herself after breaking faith with the ashes of Sicyon. Here's a, this is a slide I had, but you can even look at it. This is from the Vatican Library. It's 6th century, Codex Virgilius Romanus. So this is one of the very few examples of paintings from late Roman times, and it depicts Dido and Aeneas dining together. And here in the 17th century is a painting by French painter Claude Lorraine, who depicted the founding of the city of Carthage. And now, as everything, all information, as we've been talking about, even the simplest information, like the cycloid and its use in the development of the pendulum clock. Once this information gets out, remember Dante is 13th century, so early builders of cities throughout Europe, remember there are city walls. Florence had a city wall, Paris had a city wall, and all these city walls. This is a medieval map of Paris. There's the Seine in the middle, and then each side is almost a semicircle. This is a medieval map of the city of Cologne. That if you're going to build a wall, it's very expensive, time-consuming, and of course you want to enclose the maximal area. So all these medieval people knew that. Cologne. Okay. I learned when I was living in Florence that that in fact, even though the city of Florence goes back to Roman times, as I told you, the city was torn down only at the city walls were torn down at the end of the 19th century, even though they remained perfectly intact through those thousands of years. And the reason was the Florentines were jealous, like Hitler was, of the city of Paris. And so they wanted broad boulevards, not old medieval cities, so they simply ripped down the wall. Okay, so what is the area of a circle? Now we're getting back to this idea. And the Greeks had developed the formula of the area of the circle. Now before we can actually derive the area of the circle, as the Greeks, I'll talk about how the Greeks probably derived it, we need some basic principles about geometry that the Greeks had developed, Euclidean geometry and the geometry of plane figures. Now, the Greeks had developed a system, remember when they assigned length or magnitudes to the sides of triangles, they developed the idea of the concept of a similar triangle. Two triangles are similar. What? Do you teach this in school? Similar if and only if what? The angles are the same. So this is alpha, this is alpha, this is beta, this is beta. Now these are different sizes, doesn't matter. This is gamma, let's say. I use Greek symbols. Now, we can call this length or magnitude A, this B, and this little c. Let's call that, and let's call this side A, this side B, and this side C. Now, what did the Greeks prove? They proved that if you have any two similar triangles, their sides are in proportion. So the sides of similar triangles. This is a theorem in Euclid. The sides of similar triangles are in proportion. Okay, what does that mean? That means if you take the ratio of A over A, it's the same as what? B over B, it's the same as C over C. So if if this side is twice the size of that, then this side has to also be twice the size of that, and this has to be twice the size of that. You can't have one 3 times and the other 4 times if the triangles are similar, namely if their angles are the same. By the way, the definition of angle is another one of these things that I should point out to you. I know it's hard for students to learn it, and when I teach it in university, it's also very confusing. It's also not a very obvious thing. All of these things are very subtle. But now, so why am I talking about similar triangles? Because all of this is rather trivial and intuitive, and people will believe it very easily if you give them a presentation. Now, there's this other formula, which is the fact that you have the circumference of a circle. And there's a formula that says that the circumference now, can I call this, see here, I can't write italics or boldface. If I talk about the circumference of a circle now, here, which is the length of the perimeter, we have a formula that the circumference is pi times what? The diameter. Which means, what d is the diameter. So in particular, it says the ratio of the circumference to the diameter is some number which we call pi. For any circle. Now, the Greeks, this is not obvious, that the ratio of the circumference of the diameter of any circle is constant. I'm going to show you how they knew that had to be true. Well, before we even get to area, there's another can of worms here, another subtlety, and that is, what is the length? What is the length of a curve like this? Now, if you were Archimedes or if you're an experimentalist, there's no problem with really calculating the length. If you have a geometric figure in a plane, and you ask an engineer or anybody with a deep intuition of what the length is, what you would do is you'd simply take a cord, and you use some thumbtacks, and you glue it around, right? And you would open it up into a straight line, and then you would take a ruler and measure the length. But that completely avoids the subtlety of what the length of a curved line is. That's as subtle and as difficult as is the idea of what an area is. So, how can we define mathematically the length of a curved line? I'm going to do that before we talk about area. Now again, in order to do that, it's going to require a certain leap of faith. Okay, but first, so in order to show or argue that for any circle, the ratio of the circumference to the diameter is a constant, of course it remains to determine what that constant is, and people throughout the ages must have realized this. The Babylonians realized it, the Egyptians realized it, because they wrote down formulas for the area of the circle. And although both the Babylonian formula and the Egyptian formula were incorrect, in those formulas is embedded in the idea that the ratio of the circumference to the diameter is constant. They just couldn't get the constant right. So why is it to be constant? But in order to even show that this is constant, the definition of diameter is easy, because a circle is the locus of points equidistant from a certain point, the center. And so you start with a length, which is the radius, and 2 times the radius is the, so that's, you start with it. So the diameter is a given. It's given in the definition of the circle. The question is, what's the circumference? And the question is an intellectual one to be determined not by some physical experiment. Because even, as you know, the Platonists were dealing with ideal forms. You wouldn't want to just say, hey, we're dealing with these ideal forms, ideal curves have lengths. And in order to answer that length, you wouldn't want to go back to the real world, which, as many people thought, was ugly.